this is our Bitdeer AI platform, and you can actually come into instance to build your own virtual machines, or you can use the AI Studio for different kind of AI features, and you can explore them by yourselves. And today we are looking into the notebook portion just for a quick demonstration, right? So reinforcement learning, GRPO, and let's reserve the GPU, and let's use the PyTorch version, and I think we'll use this one, an existing volume that already comes with my written files, and you can further persist more data, let's say in the data portion, and also for example in this case I want to use a cache volume as well. So what this does is that when we load the models, when we download the models, all of this will go into this path, and later on when we go into another virtual machine and a container, we don't have to download the data again, so it's a cache part. Once our notebook is ready, we want to look at this tutorial. So this is a very simple demonstration of GRPO reinforcement learning, and a lot of the code is adapted from Will Brown's and Wayland Zhang's GitHubs. So we want to set up the environment, import the packages, and then as we all know, the reasoning models have to follow a standard. The first portion would be a reasoning process, the chain of thoughts, and then the final answer. So it will be in two sections, and we want the model to behave in this way. That's why we give this system prompt, and then some functions to help us to extract the answer. And the dataset we want to use for training is the GSM8K dataset for training on mathematical questions. And then for reinforcement learning, one important part is the reward functions. So if the model is answered correctly, in the answer itself, we'll give a reward. And if the format is correct, we'll give some reward as well. For example, it's in numeric form, we reward it. If it's in the correct XML format, we'll give a reward as well. And then maybe if the answer is a little bit too lengthy and unnecessary, we'll penalize it as well by deducting the reward. So this is how the model knows it's doing something right. It will be rewarded. If it's doing something wrong, it will be penalized. And then we configure the model. And one important thing we want to do is to compare the performance before and after the training. So for example, we have this mathematical question. We have a flower bed, a garden bed of 5 meters long, 3 meters wide. Total area will be 15. And then if we want to have one pathway of 1 meter wide around the perimeter, this means that the flower border in the middle would be of 12, the area will be 12 square meter, right? So we want to see whether the model can answer correctly. So before training, we can see that first of all, the answer is incorrect, and then the format is incorrect. It's not something that we want as well because the model hasn't been trained yet. So we can use the GRPO trainer by Hugging Face, and then start to train it. So this is the whole reinforcement training process, right? Reinforcement learning, the whole process. And we can see that, during the early phase of the training, the answer may not be correct. The format is not correct as well. So because we want to see the reasoning tag as well as the answer tag, we cannot see any of this. But as it slowly progresses, when we move down the whole training process, you can see that it's starting to behave correctly. It's starting to have the reasoning process and the answer, and likely the answer will be correct as well. So after we see the training process, we want to look at how the model behave after the training. So we will do the inference again on this trained model, and as we can see, right, the answer is structured correctly, and finally we know the answer is 12, so the model is answering correctly as well. So this is a very simple demo for the reinforcement learning process using GRPO